Hello, everyone. Welcome to our technical training day on water treatment. My name is Mark Vergdenhill. I'm the publisher of Plumbing and HVAC magazine, and very happy to start with our first session with Summit Water. With Summit Water, we have Wayne Lammers, who is going to be leading off, and he has someone with him. We have Jesse with him to help out, and Wayne will introduce Jesse. But I will give you a brief introduction of Wayne. With a career spanning over 3 decades since 1989. Wayne began as I can't speak today. Wayne began as a service and installation technician and eventually managed a full technical service department. His extensive experience encompasses both residential and commercial water treatment solutions. In addition to his role at Summit Water, Wayne operates his own business, The Water Genie, where he offers personalized water treatment services. His expertise covers both the service and installation side of the industry, and he has also provided training and technical support to other technicians and dealers. So I'm going to turn it over to Wayne, but just wanted to remind you, everyone, that we have a chat here on the side. If you have any questions at all during the presentation, please put it into the chat. I will then take your questions and ask our presenters to get answers. If you have any other problems, you can also message in the chat and we'll try to help you there. But that being it, I will turn it over to Wayne.
Thanks very much. Again, thanks for joining myself, Summit Water, with our training session today on water softeners. As mentioned, I'm with Summit Water. I'm now the inside sales manager here, and I'm joined along with Jesse Schenk today. So I'll let him do a little intro of himself.
Thanks, Wayne. Jesse here, licensed plumber, outside sales rep for Summit Water. Worked on a lot of different brands and models of water softeners over the years. So today we're just going to provide, maybe some of the common things that you'll see out in the field. So Summit Water's been around, since the 80s, doing pumps and water treatment and water reuse systems. So we got a really good team over here, and we'll throw it over to Wayne and get started.
Thanks, Jesse. So anybody that's in the water treatment industry is ultimately faced with responding to situations where the homeowner or the business might not be happy with however their equipment's working. So you're going to get a phone call, you're going to get an email, and you're going to have various complaints. So that's kind of where the process starts. And, it might be everything from my water doesn't feel right anymore, my water softener never regenerates, my water softener is always regenerating, my water bill is too high. So there could be a whole variety of reasons or concerns that the customer will contact you about. And so you're going to schedule a call, you're going to go out, and you're going to start addressing the problem. So that's kind of where we're starting at today, is how do you start with the general troubleshooting and repairs of many of the common problems with water softeners and backwashing filters. And so every good call really starts with a conversation, and it starts with a water test. So what you really want to make sure is that you leave for that site with some water testing equipment. You want to be able to test for water hardness. You want to be able to test maybe for iron, and maybe a TDS meter is a valuable tool, not just for ROs, but can also help you with troubleshooting water softeners. So you've got your test case with you. You're going into the home, and you're going to start discussing the situation with the customer and looking for clues as to maybe what's going on with the equipment. You're going to do some water testing. So the customer's complaining about their water quality. So you want to verify that. You want to make sure what's actually happening out there. So you're going to do a water test. Is the water actually soft? You're going to compare that with doing source water testing. So you've gone through that process. You've got your results. And so for today's discussion, we're going to assume that not all things are right, that the water actually tested for whatever reason wasn't soft, was completely hard, whatever the situation is. And we're going to look at exploring those situations and how to fix them. So
a good thing to keep in mind too is, you may test the water one day, you may test it a year later, and it can be completely different, or one end of town compared to the other. So it's always nice to be prepared with a test kit. Absolutely.
Absolutely. And never make the assumption that the result a year ago is the same that you're going to find today. As Jesse mentioned, water sources can change. Sometimes private wells can change. Certainly in municipalities, if there's multiple source waters, you can have fluctuations that may be a clue as to why the equipment may not be working. So always a good idea
Mhm.
to always, regardless of how many times you go back, always do your water test. And if you can always use that as a comparison to what you had before.
Yeah.
It also impacts the settings of the equipment itself.
Before you start diving into the valves, Wayne, is there a best place to test your water source? Is it the raw water? Is it after treatment? Is it hot? Is it cold?
Yeah, you do want to have as much information as possible. So always test the source water, raw water, however you can get at it. Sometimes you might have to put equipment into bypass. Hopefully, there's a raw water sample port available that you can do it. So you definitely want to do the source water. You definitely want to do the cold water. The cold water tells you what's happening right at that moment. You're running that, 3, 5, 10 gallons of water through. That gives you an immediate test result. But the water heater is a good place to also test right away, especially if it's a tanked water heater. A lot of homes now have tankless, but if you still have a tanked water heater in place, when you test that, that's a window into the background and might give you a 3, 4, 5, 6 day history that, okay, maybe it's soft today, maybe it looks great today, but geez, the water heater's got 7, 8, 10 grains of hardness in it. And it gives you a clue that on the surface it might look okay, but definitely something happened that you've got evidence of hard water occurring in the last few days. So yeah, so let's kind of start there, and we'll just, as you start the process, a good place to begin is just actually test the functioning of the equipment. So depending on the model or make that you have, we've got some old valves that we're going to use for illustration. Some of them are older, mechanical style, non-electronic. You just want to take the opportunity and advance it through the cycles. Make sure that it's doing, or it appears to be doing, what it's supposed to. So do you have water flowing in backwash? Is there water flowing in brine and rinse? Does it look like or feel like you're actually drawing the brine out during brine and rinse? Does the mechanism move freely, or is there a lot of resistance? Does it seem to grab or stick or bind? Go into like a a rapid rinse or flush rinse. Do you have water flowing? And then finally, you go back into the brine refill section, and do you actually have water flowing back into the brine tank? You can do that with mechanical styles, electronic versions. You'd have to actually just initiate an override regeneration. Just press and hold the button until it starts. And again, observe it, right? What's it doing while it's going through that process? Does it seem to function? Does it seem to pause at all the right places? And is water flowing as it's supposed to in those different cycle paths? So again, conversation, observations, water tests can go a long way in determining where there may be a problem. So again, for today, we're going to make the assumption that there's going to be a problem. And we'll talk about various problems, and we'll open up and show various components. The bulk of what we're showing today is kind of the cylinder and piston design. So there's different brands out there, different models out there, but essentially they work on or along the same principle and use very similar parts. Just always refer to your owner's manual for the correct parts and models and specifications when it comes to replacing parts. So before we actually open up the valve, we'll start with some simpler ones. So I like to start with the brine tank. The brine tank's an easy one to start with. You can take the lid off, have a look inside. When it comes to looking for, you've observed the softener and you notice that water wasn't coming out or brine wasn't coming out of the brine tank. There can be various reasons. One of the reasons we find, especially on newer installs, it can be as simple as the components attaching the brine line weren't put together right or simply weren't tightened. So this is a very common style. There's a compression nut, there's a ferrule and a crimping ring. It's actually 3 components. If I can get them to cooperate and pull apart a little bit.
Everything's harder on camera, of course.
Always, always.
Of course, ensure as well that there is salt in the brine tank. Common error.
Yeah, and we actually, it's a good point. We can talk about brine tanks and salt levels and so on. So that's the 3 components. You can see there's like a tapered end to the crimping or locking ring. There's a tapered end to the ferrule, and of course the brine nut. So that's the right orientation. You want to make sure that the 2 thicker, wider parts back onto each other. and that when you install them into the safety float assembly, that the ferrule actually begins to engage. And then you want to make sure that that brine nut, compression nut, is very tight. You don't have to put a tool to it, you're welcome to, but essentially you want to get it down to where there's less than a thread showing. An issue that can happen is you'll always pull air in easier than you'll pull brine in. So if there is a very small leak, you could actually pull air in, but see no signs or evidence of a leak. What'll happen is you'll have an elevated level in the brine tank. There'll be too much water. It doesn't lower. It's actually getting to the point where it might be overflowing, and then the safety float engages. So you're looking at a symptom of simply having too much water in the brine tank, along with a complaint of, geez, I've had the unit for 2 weeks or a month. The water was really soft when I started, but it's not soft today. So that's quite often a situation that crops up sooner after install or after brine tank maintenance. You took it out, you cleaned it, and somebody put it back together and didn't ensure that this was fully tight.
Well, we're on the brine tanks. Is there a specific type of salt you would recommend? The pellets, the rock, or a brand, or anything like that?
Brine tank maintenance is somewhat more important than salt brand. Just choose any good quality salt. There's different brands out there, different manufacturers of salt out there. Just make sure you pick as good a one as possible. Nice, clean product, well-made product. But in speaking to that, it's more important about how much salt you put in than necessarily brand A over brand B. What you want to do is make sure that that brine tank is 1/2 to 2/3 full, and kind of see, one rule is if it's a regular softener, you see the water, add some salt. So if you kind of apply those two rules, you'll go a long way to eliminating issues that you might have with brine tanks, which have nothing to do with the softener, just more about the salt and how much salt you're putting in to the equipment. The issue is, you've got this big, beautiful brine tank, and you take the lid off, and I'm going to fill this right to the top. And so by doing that, it puts in hundreds of pounds more than is necessary. That weight's pushing down on the salt at the bottom, and it's causing that salt to collapse. It makes like a thick, mushy slurry. And then what happens is the softener goes to pull that brine out, and now it's having to battle that thick goo that's sitting at the bottom of the brine tank. It might pull a little bit out, it might pull some of it out, it might not pull any out. And it'll eventually lead to hard water slippage, and the softener is not working right, but it's really not the softener that's not working right. So yeah, it's a good point about the salt. So along with the safety float assembly, you're looking for clues on, okay, I still have this complaint of I have no soft water. What else could cause that salt tank to be over full or too much water in the salt tank? So now we're going to actually start looking at the valve itself. And actually, before we get to that, I just want to make sure we don't miss something else that we can talk about without actually taking the valve apart or disconnecting anything from the piping. Every softener typically these days has a meter on it. So there's the old mechanical style meter. It turns a series of paddles and wheels and gears, and that engages the mechanical gearing on the valve. And then after so many gallons, depending on the setting, it initiates a regeneration. A lot of the newer ones have electronic meters on them. And so very similar, except that they send an electronic pulse that it works with a cable and a controller to count down the capacity. So in your testing of the softener, and you're looking at, does it regenerate, doesn't it regenerate, what happens as I walk this through, a clue you can do, not so easy on the mechanical, although there is something that you can use to help diagnose it, but it's a little more difficult. But on the electronic options, it's very easy. So you simply go downstream, turn on a laundry tap or a bathroom sink, something that should have soft water connected to it, turn the water on. And what you should see is some kind of an indicator. And on this particular model, there would be an indicator on the right-hand side, slow flashing water drop. And if water's flowing, you should see that drop flashing. When you stop the water, the flashing should stop. And after running it for long enough, you should actually see that capacity or the gallons remaining start to decrease. And so then you know the meter's turning, it's being received, that pulse is being received by the controller, and it's registering and counting down the gallons. What can happen is it's actually not registering. So you turn the water on, lo and behold, there's no flashing drop, it's not counting down, and because it's not counting down, it's not regenerating. And so now you're going to explore as to, well, why wasn't it pulsing? What's going on?
Hey, Wayne, can I interject here? We have one
Sure.
question from Alan. He says, some salts are pure salts and others have cleaning components. Any preference on which? Are some media affected by the cleaning?
Yeah, I've had fairly good results with all of them. I know that some brands of salts have some additives in it. And, personally, I haven't found that as much of an issue as I do about just general tank, let's call it practice, right? And I've used, all the manufacturers. I've used Windsor, I've used Cargill, I've used Sifto, and I personally haven't seen as much issue with the what's in the salt versus how I manage or how that customer manages the salt tank. By all means, if you have a salt that you prefer, some dealers prefer rock salt, some dealers prefer sea salt or like a solar salt, and some dealers prefer a clean manufactured pellet form. I'm less concerned about that as I am about the tank maintenance and how much you put in and when you add it. And ultimately, every salt tank needs maintenance as well. Down the road, there's certainly going to be something that comes in years later. You got to take it down, strip it down, take it outside, clean it, put it back together. But I find it less impactful of the brand of salt. That kind of hopefully answers the question. So getting to the meter. So on every meter, you'll have electronic electronic cable that connects with the controller. And I appreciate it might be difficult to see, but I can test the controller and the cable if I have a situation where the meter's not registering on my valve without actually taking it apart. So if I take a magnet and I simply pass it back and forth in front of the cable, there is actually, if I hold this really close and maybe try to simulate it, you'll see a flashing dot that appears on the controller. If I get that, now I already know that my cable is working. And if I happen to get lucky and it actually counts down a gallon, I know my controller is working. So I didn't have a flash or a pulse when I was running water, but I do have it when I test the controller and the cable. So now I know that I can actually go in and focus on the turbine or the paddle meter and look to see if that's actually the cause of the problem. And I actually, as I said, I haven't actually taken anything apart yet. So I'm going to now go down that path. I'm going to put the softener into bypass. For the most part, everybody's softener should have some form of a bypass. Ensure that you place the bypass into the bypass position and then depressurize the softener by advancing it through a regeneration. So we're going to pretend we've done that. And so now we're going to actually disconnect the turbine.
Yeah, so Wayne, while you're taking that apart, obviously this is a failed valve. We're using this as illustration purposes, but you can see the turbine is actually full of gunk and what looks to be iron. Now,
Yeah.
Is there an orientation where you would want the turbine on the inlet, on the outlet? What makes most sense for a unit like this?
So this one actually was a valve we got, and I'll point out, because in case it's not obvious, we actually got this and the turbine was in backwards. Lo and behold, it can happen every now and again. It'll end up in the wrong position, but that is important. So it'll register if it's reversed. But the problem is that you're actually hitting the turbine or the paddle with non-treated water. So every meter should be oriented so that it is on the outlet flow and not the inlet flow. There is a turbine. If you can see close in there, there's a turbine. A turbine should spin very freely. You can simply blow through them and it'll spin like crazy. Paddle meters will also turn. They turn much slower, but it becomes very obvious that that one's nice and free, but this one is actually stuck. And so if I take it, I disconnect the clamps, I take it apart, and you can see that there is evidence of buildup of debris, which happened because it was actually on the wrong side. And so it was receiving untreated water, and it actually got stuck. So it no longer was turning properly, and therefore it wasn't actually registering. And so now you've taken it apart, you see it stuck, and now you can go ahead and replace that component. So with a new one, generally speaking, if the manufacturer provides, new clamps and screws, use new clamps and screws. It can only help your cause. One less issue to deal with because you chose to use the older components.
Well, you're putting this new one back on, Wayne. I think it is important to note that obviously each valve, you have to program accordingly to whether it's a paddle wheel, a turbine, whatever the case may be. So I know we'll probably touch on programming in a little bit, but it is good to know that, it needs to be programmed for the appropriate attachments on there.
Yeah, it's actually a very good point because some controllers are designed to work on multiple valve sizes or configurations. And so you want to make sure that when you go in and check your programming, that you've matched the programming with the turbine or the paddle meter that you've got, both size and style. And it does impact it. So just kind of quick down the meter path. If you have a turbine meter and you program it as a paddle, the paddle turns much, much slower than a turbine. And so you'll have not enough pulses being read. Sorry. So if it's a turbine meter and you program it as a paddle, what'll happen is it's going to look for far fewer pulses, and your softener is going to regenerate way too often. If you actually program a paddle as a turbine, then the paddle turns so slowly it'll never regenerate. So it's very important that you set the programming up so that it matches the meter that you're using. So we've got your new part. Absolutely put a little bit of lubricant on there under all the O-rings.
Is there a lubricant that you would kind of recommend for these types of projects, Wayne?
Yeah, what you're looking for is like a food grade, preferably NSF listed, non-hardening lubricants. What we don't want to see is using like a petroleum-based product, like a Vaseline. A lot of those types of lubricants will actually degrade the O-rings or some of the components inside the valves. And so you don't want to cause yourself more problems.
Absolutely.
So any good, we happen to use this particular brand. It works very well. And don't confuse silicone, that you get from your hardware store as a silicone lubricant.
That's
so that'll cause you a lot of headaches. But any product like that, by all means, use it. We happen to supply this particular one.
Tube like that would last you a year.
A long time. Yeah, absolutely.
You don't need to use a lot.
No, that's right. That in most applications, that'll last a tech a good year or more.
Yeah.
So apply it to the O-rings. By doing that, helps prevent the O-ring from catching, binding, rolling off, or out of its position, crinkling or kinking and getting a little cut or damage to the O-ring. So insert the new meter. Make sure that you've got it oriented so that the turbine or paddle's on the outlet flow, and then install the new clips and reinstall the cable, and then it's ready to test that. So, but we're going to go down the path further, and we're going to look at other situations that might be occurring. So again, we talked about the brine tank. We talked about there being maybe too much water or not pulling the brine up from the brine tank. And so there's other things that might cause that. And every water softener has some form of an injector on it. It needs to have the ability to create a vacuum and literally pull that brine in from the brine tank. And so on this particular unit, it's got a separate brine valve body. So I'm just going to take it apart, take the cover off, injector cover, and then inside this one, you've got a screen. Screens are used to make sure we don't get big debris entering the injectors and plugging the injectors. And so you might see where the screen gets really dirty, maybe some iron buildup or some other debris. You want to make sure it's nice and clean. If it's not, or you can't clean it, then simply replace it because that could restrict the water flowing through the injector and prevent it from functioning. Then you've got an injector. So again, we're looking for debris. This is a little older style. It's a two-piece. It's a throat and a nozzle.
What
They
would you
just
say is
thread
the
in.
most common sign of a plugged injector, Wayne?
Again, you've got where you put it into regeneration, and it's not pulling that brine up from the brine tank. You've got that overflowing brine tank. And so there's the other part. Typically, they're always color. If they're two pieces, they have to match by color. You might have a situation where it's a single piece. For example, on this valve, it has no separate brine valve body. It's just molded into the valve, and it uses an assembly that comes together. And so again, they're matched. It's actually two components, but they come as one piece, and they're color coded and matched accordingly. So for that,
one
again,
other question there, Wayne. Do you recommend using KCI as water softener salt?
Oh, so potassium.
Oh, that was small here. Sorry.
Yeah. So the issue with potassium is it will work to regenerate. I'm not a particular fan myself of potassium. Couple of issues. The first one is you need more. The rough rule of thumb is you need 20% more potassium than you do sodium to achieve the same regeneration results. It's harder to get, and it's far more expensive. So it's been a little while since I priced it out, but there was periods of time there where, a 20 kg of potassium was, $25 or more for a bag. So it's, 2, 3, even 4 times the price. So I'm not a particular fan of it. It will work if you make accommodations for it to work. There might be other reasons why that homeowner or customer wants to use potassium. It wouldn't be my go-to unless there was very specific reasons for selecting it. So
I think it's very important to know too that this industry is very wide. So there's a lot of different opinions, and some are right, some are more right. So it really depends what works for you and your customer as well. So
yeah, good points. So in regards to the injector, we've got the old ones taken out. We've got a screen, and we've got the new ones. And so we'll go through the process of replacing those. But I'm going to continue with taking apart the brine valve assembly because there's more components to it. There's also a brine line flow control. So there's some form of mechanical piece or component in place that governs or throttles the amount of water entering the brine tank. And by slowing it down, we make sure that we get good control and we put the right amount in. And brine line flow controls and drain line flow controls are very similar. There's generally small components. In this case, they happen to be a small rubber type of disc, very small for the brine line flow control. And you see there's a little hole in the center. And so that hole is actually fairly easy to plug up with debris. And so that's the first line or the first component that the brine hits when it comes up from the brine tank. You might have had some debris, some dirt, maybe got into the brine tank and got pulled up that brine tube and got lodged inside that flow control. They're rated, so always refer back to the manual for the right size and specifications. But then there's also, a rule that it has to face a particular direction. So when you look at a flow control, there's a beveled side and there's a flat side for the center, for the hole that's in the center. And you want to make sure that that beveled side faces the flow, because its job is to adjust itself based upon pressure so that it always throttles or regulates the amount of water going through. And then when you take it apart and you put it back in or replace it with a new one, you want to make sure it's going back in the right direction. And so there's numbers on it. The numbers will equate to a certain flow rate. You want those numbers to face the valve, right? And so when we put it in this unit, the numbers will face away from me. I reinstall the retainer with the flow control in, and now the numbers actually are on this side that gets threaded into the valve, hence that faces the flow. So we've replaced the flow control, and now we can go ahead and put that piece back in.
One question here as well, Wayne, from Kyle. Some softeners come with different sized injectors. What are the different sizes for?
So the injector size is based on what we're trying to achieve is a consistent flow rate of brine entering the softener. And softeners come in different sizes. So, and as the size goes, so does the diameter of the tank. And so we're trying to achieve a certain brining window. The rough rule of thumb is approximately 1/3 of brine and rinse time we want to be pulling the brine in. And so that injector is sized so that the rate of draw accomplishes that. So whatever weight of, we'll just throw 10 pounds out there. If we have a 60-minute brine window and rinse window, that we're trying to pull that brine out at about 15 to 20 minutes. And so that's very slow draw. It's a very even rate of draw. And so that it enters that media tank and flows through the media tank at a particular speed and density. And so by having different size of injectors will accomplish that variance or that different rate of draw. Because as the injectors get larger or smaller, so do their rates of draw. So hopefully that helped answer the question.
Yeah, well, Wayne's putting this back together too. I think there is a good point to be had. I mean, don't be ashamed to take pictures of things while you're taking them apart, especially if it's a model you're not familiar with. Might help you on a Friday afternoon to get out of the house a little bit earlier and not be there all weekend. So
fair point. Especially if you haven't done it as often as maybe others have, and it's not second nature. So pictures are certainly a valuable tool to have. I put a little bit of lubricant on that threading as well. Again, I make the assumption that maybe I'm the guy coming back in 6 months or a year or 3 years, and I want that to come apart as easily as it did when I got there, if not easier. So I put a little bit of lube actually on those threadings as well. Helps the O-ring engage without catching or binding and tearing and maybe causing a leak. So we've got the flow control adapter back in place. There's also, in this model, there happens to be a drain line flow control in the same assembly. So much like the brine line flow control, the drain line flow control is also sized to match the specifications of the actual softener or filter, right? It'll have a rating on it. Again, the same rules apply. You want that flow control to face the flow. When you take it out, is it plugged? Maybe a slow run to drain or a restricted run to drain. You might have some obstruction or some buildup of debris on that flow control. And again, it does need to match based upon the manufacturer's specifications to the appropriate size. There's different models. This happens to be a pop-in drain line flow control. Same thing. It's got a flow control in it along the same lines as this one. So we've taken it out. If it shows signs of being dried or cracked, you want to go ahead and replace it. And again, flipped on me. So we want to make sure it's facing in the right direction, and then reinstall the retainer in this case to hold it in place. Another thing that might cause issues with the brine tank, improper brine draw or leaking to the brine tank where it's not in regeneration, but water comes out to the brine tank all the time. That's easy to test. You take the brine line off, you're in the service position, and water is flowing out the tube into the brine tank. And you've got this elevated level of water in the brine tank. It can actually be a leaking brine valve assembly. So in this particular version, it pops out. It's very much like a main piston assembly. It's spring-loaded. It's got an internal seal on it. So when it goes into either the brine and rinse or the refill positions, it opens up, lets water go through. It's got a couple of O-rings on it. And so if it shows signs of where maybe there's corrosion or buildup on it, it's very stiff, it's really hard to push in and so on, that can cause issues where it backs up onto the gearings and the mechanisms inside the valve. You want to replace it. It's got a coating on it. If the coating looks like it's etched or scored or something, you want to replace it. So the kits typically will come with extra things like O-rings. In this model, there's actually an internal O-ring as well. You want to make sure that's removed and replaced. And when you put the new one in, I've got a new one here sitting here somewhere right here, that the O-ring is actually installed first, and that O-ring needs to be set right down into its little home or seat position. If you try to place it on the brine valve assembly first, you'll end up with it rolling or pinching, and you'll end up having the leak to the brine tank all over again. So it's sitting, I'm not sure if that shows it, but it is sitting in there nice and square. And then just insert the new brine valve assembly, and you'll see it's flush fit to the top, so you know you've engaged that O-ring, and that part is now ready to go. There's some more O-rings on some of the porting. Make sure those O-rings are in good shape. If they look reasonable, you don't want to replace them or you don't have them. Again, put a little bit of lubricant on those O-rings, just helps to extend the O-ring life and ensure a seal when you put it back together. So we won't put that back together just yet. We'll keep going on the tear down.
But wait, one other question here as well.
Yep.
From Jennifer. How often do you
Sure.
recommend the full service be done on a commercial size softener versus a household?
So typically in softener applications, you do, as a rule of thumb, unless it's in an adverse situation where you know you've got maybe some iron you're dealing with, residual iron or manganese, that would be more of a maintenance goal. And you kind of have to learn your customer and determine, okay, maybe we'll go 24 months. At 24 months, maybe you do a maintenance call, you open it up, you inspect it, everything looks pretty reasonable. Okay, maybe we'll go 36 months. Residentially, typically we kind of let it go until you see signs of a failure. You have got a complaint, it's not working. There are some things that impact the life of certain components inside, like chlorine and chloramine, and we can touch base on that in a bit. Where, especially in a commercial application, you might be going through a huge volume of water. The exposure is far higher to those kinds of oxidizers that might necessitate more of a maintenance approach to things like seals and spacers versus waiting to failure, especially in more critical applications. There's no hard rule about it. It's more about kind of getting to know your customer and the volumes of water they're going through, and then their desire to, look, we'd rather invest in some preventative maintenance at 12 or 24 month intervals. Please come out, inspect it, change some of the key wear and tear parts, and continue. But typically in the residential application, yeah, we kind of wait for failure as far as softeners go. Filtration and private well applications, a different scenario. We can certainly answer some questions about that. It's not really the focus for today, but certainly that may change the answer. So we still got some concerns. The customer is saying, my softener is running to drain continuously. I'm still not getting, you haven't found any problems here. Nothing answers the question about why it's not pulling out brine or why I've got too much water in the brine tank. So you keep diving into it. So now we're going to look at the main piston, seal, and spacer area and look for evidence of failure or damage there. So on the back of this unit, like many units, there'll be a main piston, there'll be a main drive gear, and there'll be a piston link, and that link is kind of held in place by a component screw and a washer. So we're just going to continue to take the controller apart. Some of the newer ones, different brands and different models, they come apart much easier. They snap apart, don't require a lot of tools or any tools to, or maybe one or two specialized tools. This one's a little older design, thousands and thousands out there like this. So we're looking at ones that are a little bit more to take apart. You can see there's a number of gears in here. We're not going to take the gears apart today, but there's salt cam gears, main drive gears, idler gears. There's a drive timer motor for working or putting the software through regeneration. So we've got the controller separated. So now we're basically down to the valve body itself. So again, valve bodies are quite often one main part, and then various controllers can go on to work along with the valve to work as a unit. So we'll take those apart.
Yeah, well, Wayne's taking this piston out too. It is good to note, with technology and stuff like that nowadays, if your customer is, willing to send you a picture of the unit before you go, it's nice to do a little bit of research, or maybe have some parts handy with you, just so you don't show up unprepared or not knowing exactly what you're getting into. It can make for a long day for you and your customer.
It's actually a really good point. Everybody's time is valuable,
For sure.
the customers and the dealer and the technician. And so by having a service kit with some key components, especially if it's valves and systems you're used to working on, by all means, take that along with you with the test case, because it's a whole lot nicer to fix the problem the first time, rather than having to go back and complete a second or more calls. So we've got the bracket off. In this case, there's a bracket that kind of holds this assembly in place. And in this case, we're pulling out the piston. The piston comes as a unit. A lot of them now used to be able to buy components. Now, typically, they come as kits or assemblies. So that's the complete piston assembly. You'll notice it's got a green top on it. A lot of brands and manufacturers color code their pistons or their caps. They'll use different link configurations. All those things kind of indicate, is it for a softener? Is it for a filter? Is it upflow? Is it downflow? So the cap on there is an indicator. We'll set that one aside. There's other ones. They'll come with more square caps. And then in this model, for example, there's a tiny little color code on there, a little white dot. The white dot indicates downflow. If it was an upflow valve, it would be a blue dot. So always, again, go back to your manual, make sure that you're getting the component or components that you need for that piece of equipment you're working on. So we've got the piston. We've taken apart the seals and spacers. In this example, they're all separate seals and spacers. Typically, there's always one more seal than spacer. You want to take them all out. So they're all out. And now you want to look at them. So a piston might get stuck, might cause damage to a valve, or might simply get stuck into a certain position during regeneration. And that can happen because the individual seals, again, we were talking about chlorine and chloramine, they can be attacked by those oxidizers. They'll dry out, they'll crack, they'll become brittle or stiff. And then as that piston tries to move through that whole assembly, it'll bind and catch on all of those high spots of the piston. And when that happens, that exerts pressure back on the other gearing and the drive motor, and might lead to a failure on some of those other parts. But at the core of it, the cause of it, we're dealing with a seal or seals that have been damaged. Spacers, especially in filter applications or extreme hardness applications, they might get coated or gummed up with debris, with contaminants, and then that can also cause wear and tear, friction, resistance on the pistons. The piston, you're looking for any scoring. You might see lines etched in, or pieces of the coating worn away or pitting. If you see any signs of that, simply replace the piston. There's a seal or an O-ring inside the cap on all the different models. If you see evidence of water leaking out and over the valve body, then that cap has leaked and you want to be, again, switching out or switching out the piston. If in doubt, if you're, geez, does it look good? Doesn't it look good? You're this far along, you see that there's seals and spacers, you know, a recommendation might be, look, Mr. and Mrs. Smith, maybe we should also replace the piston assembly. I'd hate to come back in 6 months or a year. Your choice, your call. It looks okay, but always err on the side of caution. Make the recommendation, let the customer choose, also goes a long way into making sure your customer's going to be happy. So that's the piston assembly. So we've seen some evidence of damage, so we're going to set those aside. We're going to install the new set. Again, double check your kit, make sure your count is accurate. You should have an extra seal. Some people like to put a little bit of lubricant on these seals, some don't. If you do, use sparingly. You know, keep it between and to the outside and not necessarily to the inside. What you don't want to have great gobs of lubricant on there and it starts to catch other debris, and then it actually can cause some damage to the piston or to the coating.
Yeah, and as Wayne's kind of putting that back together, he did mention, you know, chlorine, chloramine. So these come into play with a lot of these rubber components in your unit. So not saying you have to upsell every customer, but I mean, you can educate them on a dechlorinator, things like that. They might not even be aware that, you know, a carbon filter could prevent a lot of this maintenance down the road. So not saying you got to sell everybody everything that you've got, but if they're not educated and they don't know about it, then that's a problem in itself. So sometimes just an extra piece of equipment can prolong the life of your softener or your filters down the road for sure.
Yeah, and they might also, along with helping their equipment last longer, they might actually like the water better.
Better for
You know,
showering.
better for showering. People have hypersensitivities to
For
chlorine and so on, so they might appreciate the fact that you mentioned it. You know, and maybe will want to have that extra upgrade to their treatment system. Of note, the seals and spacers. These particular ones, they're doesn't matter. There's no up, there's no down. They do have some grooves and notches, so they align and make a tight fit from piece to piece. Again, you know, rotating seal spacer, so you get to the top. You'll always start and end with a seal. So now you've got all the seals and spacers back in place, and you want to install the new, not the old, piston assembly. Simply drops into the in between the components in the cylinder, and now that is ready to begin reassembly of the valve. You'll notice that the piston cap is actually not, hold it up nice and close, is actually not flush with the top of the valve body. That's normal. On these components, what will happen is as you put your retainer, your bracket, whichever model it is, back in place, that will actually push down on the cap and squeeze or compress the seals so that it fully seals, is a nice tight fit around the piston. So we've got that in place. We'll start putting the screws back in.
Just like a tire, you don't want to crank one down and then go to the next, crank it down, kind of do the little star pattern.
Yep.
Even though this model's only got 3, just take your time with each one. No point in cranking one down. And like most of the components on these valves, there's no need to get out pliers and wrenches, and a lot of this will just be very snug. You'll be able to see, you know, if the gaskets are seated, things like that. So,
and I'm also I like to, again, approaching it from the aspect is I might have to take this apart in 2-3 years again or something. Nothing wrong with a little bit of the same lubricant on the threads. It just helps the machine screws slide into in this model, there happens to be brass inserts inside the molding. And so it just helps ensure that it turns nice and free and that it doesn't get stuck per se or seized and you've got issues taking it apart in the future. And so you just tighten it up, you look for, you can see there's still a bit of a gap there between the plate and the valve body. Just keep tightening it evenly so that the bracket flattens out.
Yeah, it's good to know too. A valve like this can be taken apart with any tools that the plumber should have in their tool bag. Some models have their own, specific tool to take everything apart, but this is a pretty common valve you'll see in the field, and a lot of them, depending on the brand, will be very similar. So,
And now that that's back together, you can tell there's a certain amount of resistance as you try to move that piston up and down. That's normal. The bracket in this particular model also helps to secure the brine valve assembly in place. So now we're ready to put that back in. So that just kind of nestles into place. The brine valve is being held in by the bracket. We're going to put the screen back in. We're going to put the injectors back in. And again, when you install these ones, thread in place. It's just so they're snug. They seat out, just snug them up. Put the next piece in. That's it. That's all it takes. Your screen's back in place. The injector cover will have some form of a seal or gasket. Inspect it, make sure it's in good shape. Apply a little bit of lubricant to it. Put the cap back over. Reinstall the set screws.
Wayne's done hundreds of these repairs in his day with this particular valve. It's maybe not quite as easy if it's your first time or second time, but it does get easier the more you do them.
Yeah, a few.
A few,
5 or 10.
5 or 10 maybe.
So that's nice and straight and secure. And so we've got those components back in place. We've got the meter on there. We'll make sure we want to tighten those back in. Typically on this design, we would put it back on when we reconnect it to the bypass, but we'll just put them on there for right now for demonstration. Again, they should line up nice and square and engage both the turbine and the bypass valve. Make sure that they're not kind of crooked or offset. You'll know it when you turn the water back on if you didn't put the bracket in the right place.
We have one other question here.
Sure.
How about media replacement? Do you have a recommendation for timeline or go with checking output water hardness?
Yeah, so media replacement. If it's a case of capacity attrition, so it's losing its ability to soften the water, typically that takes either a really long time, like in a residential application, we're talking years and years, or adverse situations where you've got really high hardness, heavy use. Again, resin. So once upon a time, you used to be able to get 20 plus years out of resin. Those days are not necessarily the situation anymore. But more so, we find that we'll lose resin integrity because of the oxidizers that are in the water. So the chlorine, the chloramine will start to attack the resin, especially if it's a 7 or 8% resin over time. It starts to break down the resin swells, it loses its integrity, it won't soften anymore. You might result in pressure loss.
Absolutely.
And the homeowner will turn the water on and they've got no water flow. You're running the tap, you turn your, normally in your service position, with the water running, you turn it into bypass, and the water just starts flying out like crazy. There's a huge increase in pressure. That would be certainly an indicator that you might be dealing with fouled resin. Worst case scenario, you disconnect the softener, you spin the valve off, and when you spin the valve off, the resin literally bubbles out over the top of the tank. That's extreme resin damage, and you've got to replace it. If you, when it comes to just capacity attrition, if you do regenerations and you get soft water coming out, but doing the math, the numbers don't work out anymore, right? So typically, let's just use, I should get 24,000 grains recovery with 10 pounds of salt, using some older numbers. and you have it all set up and everything works, and you know it works out to whatever 1,000 gallons or whatever the number is, and you get to 800 gallons, and the water switches, it's no longer soft, and you do this a couple of times, and everything's functioning. You're just not getting the capacity in gallons out of that unit anymore. That might be an indicator that everything else is okay, but the resin's lost its ability to give you the full capacity out of the volume of resin, and would be an indicator that it's time for resin replacement. So.
Okay. And just wanted to let you know, we have just over 4 minutes left in this.
Okay. Well, we're getting close. We're going to get this valve back together. So we've got the piston assembly back in place. We've got the brackets on. We slide the controller back on. If there's any kind of a bracket or securing place on it, you want to make sure that the controller's fully in position. And then if you've got a piston link, you want to make sure the piston link aligns, if everybody can see that, with the drive gear. And so that as the drive gear turns, the piston moves up and down, and that it's able to slide back and forth through the piston link. There'll be a component screw. Engage the component screw. Put on your last 2 machine screws. And then you've got it all back together. And now, of course, you need to fully test your repairs. So you're going to have to back up to the bypass valve. I always recommend engaging or placing the valve into the backwash position and turn the water back on. If you got any air in the system, it's going to evac the air. You can walk it through. And at that point, you can step it through quickly back into the service position and literally start checking everything. So walking it through. Does it advance? Does it move freely? Put it into a backwash. Do you have good backwash flow? Put it into brine and rinse. Do you pull the brine out? Do you actually watch and make sure that the brine starts to drop in the brine tank? Does it rapid rinse? And then if you had a situation, you've got it all back together, everything tests good, it's functioning. Every time you go into an application and it hasn't been working, always plan for that it was a worst case scenario. So it's functioning, you're going to set it up for regen. I don't recommend you watch it, do a full regen because time is valuable, but you verify that it's going to work. You can, at that point, put it right into regeneration. If it hasn't been delivering soft water, then it doesn't really matter in the first place. Let it walk through, and then instruct or ask the customer to please put it into regeneration tonight, maybe once more tomorrow night, because what you want to do is get that resin back to its full regenerated capacity. If you've got some cleaner products that are typically used, maybe like a ProRes Care or something like that, where there's additives that are used, you might want to do an extra dose of that to help ensure that the softener's back into its full functioning capabilities.
Absolutely. And Wayne, obviously we've got about 1.5 minutes here. We could talk about this all day. Well, sure. I know you certainly could. There's some great presenters today. We want to obviously thank you for this experience with us as well. You're more than welcome to reach out to Summit Water at any time. We're more than willing to help you with anything or any questions you got. Absolutely.
Yeah, and you can always email to sales@summitwater.ca with any questions you have, and we'd be happy to provide assistance wherever we can.
Yeah, I want to thank you both. That was a great presentation. And yeah, you're seeing comments in the chat. Thank you as well. And I'm amazed how well you guys timed it. You finished perfectly right on the dot. So
we never rehearsed once.
So we got about another half hour if you want.
Yeah, very, very good. Well, we do have to move on. We actually have a great presentation next on water solutions for healthcare concerns. So.
All right. Well, thanks very much for the opportunity.
Thank you very much for joining. Again, this presentation, any of you can come back in and rewatch it again on this website but we also will be placing it on our Training Trades website and also our YouTube channel if any of you guys want to refer back. But please also reach out to Summit Water with any additional questions. I'm sure they'll be glad to help.
All right.
So I will stop here. Thank you, guys. And please join us in our next session, everybody.
All righty.
Yeah.
Take care.
Thank you.